There we go. Hello.
Can you hear me?
I can hear you now. Yeah. Hello, Don.
Yeah, I can hear you too. So,
Okay,
okay.
brilliant. Yeah. So, yeah, nice to meet you.
Yeah, good to meet you, George.
And how are you? How are you today? It's what, 10? I think it's 10 o'clock where you are.
Yeah, it's a beautiful morning here. I'm in California, Southern California, so it's another beautiful day. Where are you?
So I'm in the UK, somewhere in the middle of the UK, maybe about an hour and a half. No, probably, yeah, just shy of 2 hour drive north of London.
Okay.
Yeah, yeah. Um, yeah,
Is it
which
is it
it's
rainy there
cold.
now already, or
Yeah, yeah, it's dark, it's rainy, and it's cold. It's
rainy and cold?
yeah, it's pretty standard for British weather. Um, yeah, and so I mean, because I know I've seen you mention it before in places. You like to sit in the quiet um quite a lot. Is that something you do in the mornings, or do you like to do it in the evenings?
I do it. Fortunately, my schedule is flexible enough that I do it often. So I do it at night. I'll do it in the morning. I'll do it in the afternoon. So whenever I have a little break, I'll sit and meditate and and let whatever happens happen. So it's a very, very good practice. But I end up spending quite a bit of time each day in meditation.
Mm,
How about you? Do
yeah.
you meditate or?
Yeah, yeah, I do. Yeah, yeah. Yeah, I cottoned onto it. Well, I say cottoned onto it. Someone, uh, um, mm, I'll tell you how I first got into it, actually. Like, I imagine a lot of people is one of the apps. As someone mentioned, have you heard of Headspace?
Yeah, I've heard of it, but I've not participated much.
Right, right. And so essentially, it's like just watching the counting the breath. Um, which was quite a nice introduction. However, actually, I found, and I think this is why when you shared about your sort of meditative practice, I find it really interesting because, unless you might correct me, but it sounds as though it's quite sort of unstructured because obviously you do have quite a lot of, you have like Vipassana where you sort of like pay attention to particular sensations and people, or, you have like a transcendental where somebody, you have like a word
Well,
and you
mantra.
repeat it. A mantra, right, right, right. Whereas for you, you sort of said you just quite literally sometimes, yeah, you just sort of sit in the silence.
That's
Um,
interior silence. So that's the point is letting go of all thoughts and
yeah, yeah.
and being there in utter inner silence. Outer silence helps, but the key is utter inner silence. And of course, when you do that, most of the time thoughts are coming up. And so learning to disidentify from the thoughts, just look at them, watch them, but not identify them, and also the feelings that come up. And when you do this process of sitting there in utter silence, um, it transforms your your ego, right? The ego that has all of its problems and is trying to be important and complains and so forth. that that doesn't want to go. And so when you sit there in silence and you just be the silence instead of the ego doesn't like it, and so all these emotions come up, and it's really so the way I think of it now is that all that energy that's in this dysfunctional ego, tons of energy there that's in all of us. We're born with it, and so it's just nobody's fault. It's just the way it's just the human condition. But all that energy, as you look at it, just watch it. You don't condemn it. You don't try to get away from it. You don't think about it. You just watch it. And that's enough. Just all you need to do is no big deal. You're already the pure consciousness. You already are that. That's what you are. So all this other stuff that's coming up is just raw energy that you just look at and it gets transformed into your pure consciousness. But and it depends on the person. I mean, some people, it happens overnight. They just go from ego to no ego overnight. I mean, it's not very many, but there are some like Eckhart Tolle,
Yes.
overnight, completely. Whereas someone like Don Hoffman, I've been at it for 30,000 hours and 20 years and 20 plus years. And so, you could say, well, maybe my ego was a lot worse than Eckhart Tolle's. And I don't know, maybe it might be, but I suspect that he was somehow able to let go in a much deeper way than I've been able to let go. And most people are more like me, I think, that it's a gradual process and at times painful, but then it's very helpful at that point to actually have someone that's been through it ahead of time to talk with, because sometimes the death of the ego feels like the death of you, because you still identify with the ego, so it feels quite painful. And it's this, you might say, well, this is just spiritual stuff, but what about the science? And it seems to me that there's a deep connection between this and the science, in the sense that right now our science is based on a physicalist assumption that space-time is fundamental, and what we are fundamentally are just objects in space-time. And consciousness is a latecomer. And we have to figure out which physical objects might have consciousness and which don't, and what physical properties of systems create consciousness and which don't. And that is the framework of the ego. The ego thinks of itself as a small little object, and it needs to get its significance somehow. And so that's what we're letting go of, and recognizing that almost for obvious logical reasons, I'm not just something that I perceive in space and time, like a body or a person or something like that. I am the ability to perceive. That's what I am, is the ability to perceive. And among the things I perceive is something that I call my body, which is just an avatar in this VR that I'm creating. And so it's a one way to think about it is it's a change. If you're playing an immersive virtual reality game, you put on a headset and bodysuit, and if you go into the game knowing that your avatar in the game is not you, that's just your avatar in the game, and if it gets shot up, if it gets put in perilous situations, enjoy it. I mean, there's no, you in some sense, you really have no skin in the game, right? That's just your avatar. It's not you. But if you are identified with the avatar, then it's a completely different kind of game, right? Now, anything that attacks the avatar is going to get a huge emotional response out of you. You're going to be scared. You're going to be sweating. It's a completely different thing. And so it's a real question, a scientific question. Is space and time fundamental? And are objects inside space and time fundamental reality? Or is space and time not fundamental and something else is deeper? This is a deep scientific question. And so this deep scientific question parallels this question in science and spirituality, which is the ego's view of the world correct? I'm a little object in space and time. I need to try to make myself meaningful, and I need to compete with you to be more meaningful, more important, more special than you, and so forth, before my 80 years are up and I'm gone. And then that's the end of me. So I'm trying desperately to make some sense and meaning out of my life, given that I know that I'm just this little tiny object in space-time, and I'm only here for under a century, which is a flash in the pan. So I feel like I'm a flash in the pan, and I'd like to be more. And so it's a so I need to get a better car than you, better house than you, whatever it might be, more publications than you if you're an academic, whatever it might be, show that I'm smarter than you and know more music than you, can play tennis, but whatever it might be, we do it in 1,000 different ways, trying to get significance. So that's one view of the world. Another view of the world is, hey, I am an infinite consciousness. And so are you. In fact, you're the same infinite consciousness as me. We're just the same consciousness looking at itself through different avatars. And that's the source of true love. I mean, I don't need to compete with you because I am you and you are me. And that's the foundation for true love. Now, of course, there's a technical question then. As a scientist, physics for centuries has said that space and time is fundamental. The universe is space and time, or after Einstein, space-time. So is that true? This is now just an empirical question. Is space-time fundamental reality? If space-time is fundamental reality, then all this spiritual mumbo-jumbo I'm talking about is just that, mumbo-jumbo. If space-time is fundamental, I mean, that's the reality, and consciousness is latecomer, then I'm not this universal infinite consciousness. I'm 150 pounds of particles in space-time that thinks it's something special or trying to make itself special, and so forth. So, but the physicists, the nice thing about the physicists' theories of space and time is that they're mathematically rigorous. Einstein, well, if Newton had mathematical rigor, but Einstein kicked it up a notch with this special and general relativity. And then quantum theory, when you put the mathematics and ask the question, is space-time fundamental? The answer is no. Space-time is a fairly shallow data structure. It falls apart at 10 to the minus 33 centimeters, the Planck scale, 10 to the minus 43 seconds. So it has no operational meaning. And that's, I say shallow, it's not 10 to the minus 33 trillion centimeters, just 10 to the minus 33 centimeters, and it falls apart. It literally can't do anything anymore beyond 10 to the minus. That whole framework coughs up nonsense after 10 to the minus 33 centimeters. So it's just nonsense. So many high energy theoretical physicists are now saying that space-time is doomed. And that's actually a quote, space-time is doomed. It's not, by that they mean it's not the fundamental reality. If physics wants to get a fundamental description of reality, they're going to have to go deeper than space-time. And of course, whatever they find, they'll need to project it back into space-time, because that's where we can get our data, where we can make measurements. So from my point of view, by the way, most even quantum theorists that I've talked with who are not high energy theoretical physicists don't understand that the high energy theoretical physicists are saying space-time is doomed, and the reasons that they're giving for that. So this is right now a small group of even physicists who understand that space-time is doomed. But there was a time when there was only one person who understood that Newton was wrong, and that was Einstein, right? So you have to start somewhere. Eventually it catches on. So my take is space-time is not fundamental. And of course, that doesn't prove that the idea that we're just consciousnesses, and in fact, unbounded consciousnesses is the right one. But put it this way, if space-time were fundamental, I would, as a scientist, count that as clear evidence against the hypothesis that we're just pure consciousnesses. So the fact that space-time is clearly not fundamental is a nod in that direction, that maybe the alternative view that consciousness is fundamental. And I think it makes sense on logical grounds. To have perceptions of space and time, there needs to be a perceiver. To have probabilities, you need a probability space, right? So to talk about probabilities of events happening, you need a mathematical probability space that's prior to those events actually happening. So that's a more mathematical way of saying it. But what's interesting for me is, as a scientist and as a human being, is that I'm giving all these nice logical arguments, but my emotional state is largely tied up with the egoic beliefs, right? I'm largely governed. My knee-jerk reactions are, I'm not significant. I need to do something to be significant. I need to compete with others. And that's just sort of in my evolutionary psychology. Right? So the evolutionary theory is an incredibly good theory about what's going on inside space-time. I think it will have to be revised when we go beyond space-time in our science. But within space-time, we have no better theory about human emotions and motivations than evolutionary psychology. And I think it describes well the egoic state of mind. And so getting back to your question about meditation, for me, the meditation is dealing. It's like, I guess it's actually in some sense part of my research. I'm letting my meditation time free me from the emotional bondage to a sense of a tiny self, a little me inside space and time that's struggling to find significance. If that's in fact false, then it's an impediment to me as a scientist to continue to have an emotional attachment to that. I need to let that go so I can move on and actually consider new scientific hypotheses that are I don't think we'll ever get the truth, but that will at least not be false in that particularly dumb way. So it's sort of a long riff on your question, but yeah.
Yeah, well, it was a really great riff because it I think a lot of it introduced perhaps somebody listening by chance this is the first time they've encountered you, and maybe haven't read your works in terms of like maybe your book or your papers, then yeah, I think that's quite a nice introduction to the sort of general thesis, and sort of maybe not thesis because that sounds too unitary, but like your sort of your work and you as a person, actually, because I think that's really important because it makes me want to ask, which is so I mean, I believe William James said it, essentially that, one's metaphysics is essentially determined by one's temperament to an extent, in that, you'll often find you could leave them, what you might call a materialist and an idealist in a room, and you could give them the same set of facts, and, neither would necessarily budge. I mean, I think that's probably for when you add in a bit of stubbornness into the person's character, that was probably what happens. Right. But for yourself, I'm curious in terms of your intellectual journey. Now, I know you mentioned it. I think it was in your book. Because I know you wrote some academic ones. The more popular one, why reality hid the truth.
Reality.
Case against reality.
Case against reality.
So sorry, yeah. And in that, you obviously sort of speak about your kind of conversations and debates with some of your colleagues, and how you sort of came up against them. But yeah, so just generally in terms of your intellectual journey, how you got here, and I suppose my question would be: did you bring a metaphysics upon science, or do you feel as though the science led to this sort of metaphysics, or perhaps it's not as binary as that, and it's this kind of, you had a sort of inclinations and sort of like these sort of intuitions as a result of who you are, and then the science and the findings of science have sort of borne that out a bit more? Does that make sense?
Right. Yeah. So it's a great question. And one thing I would say is that human beings have had, of course, their opinions and ideas, and they've debated them and held them in high regard or for thousands of years. What science brings to the table that's new is mathematical precision. And so it's not enough to just have your ideas in science. You need to state them precisely. Like Einstein, when he wrote down his field equations for gravity, right? His idea was that if you're in an elevator and you're standing on a scale and you're weighing yourself, and all of a sudden the cable is cut and the elevator falls, free fall, your weight on the scale would suddenly go to zero. That was the big idea. Turning it into mathematics took him several years, and he was Einstein. I mean, he was a smart dude. So this is not easy work, but that's what science requires. And when Einstein did that, then you have something now where you say, okay, so that's precisely what you mean by space and time and their interaction space-time and gravity and mass. That's precisely what you mean. Aha. Well, if that's what precisely you mean, then it's precisely the case that at 10 to the minus 33 centimeters, your whole framework falls apart. And that's the key in science, is when it stops dogmatism. Now, individual scientists, maybe they'll die before they give up their theory. So, I mean, that's fine. I mean, individual scientists are as dogmatic as anybody. But the field, as a social enterprise, science will have trends, but eventually, if something has a limit, you're going to say goodbye and move on. So space-time has been a wonderful gambit. It's been a wonderful framework for more than a century. But space-time is doomed. And so for me, that was what I was looking for in looking for these questions about who am I? Am I just an object in space-time? Or could I be something more than that? One reason I turned to science was, well, I listened to what the spiritual traditions had to say, and there's many of them, and they'll say various variations on, you're not just an object in space-time, you're deeper than that. You're consciousness or something like that, or you have eternal life.
Like the Upanishads, for example, speak a lot of that. Yeah. Sure.
The Tao Te Ching, the New Testament, the whole bit.
Yeah.
So there is a sort of a common theme among all of them. There are, of course, important differences that people fight to the death over sometimes, but for me, so I was raised in a Christian framework, so I read the Bible cover to cover, and so I knew that framework pretty well. But there are no theorems and proofs in any of these traditions. Whereas in the science, you have theorems and proofs, and not proof that you're right, proof of the limits of your theories, and that is the key. See, in the spiritual traditions, they're saying all these things, but when you say, okay, but of course, the traditions will say, our words are just pointers, so they're not the truth. The Tao Te Ching says the Tao that can be spoken is not the true Tao. And once you understand that, then you can go ahead and read the rest of the Tao Te Ching in the proper framework. Don't be dogmatic about these words and this phrasing and so forth. Use the words and phrasing to go inside yourself and try to understand something that in some sense transcends the words. But at least these words can take you into new places of understanding that you might not have gone on your own. So that's the function of the words. And we then get addicted to the words and fight over them and kill over them and so forth. So what science brings to the table is scientific theories themselves are just pointers. They're not the truth. There's no scientific theory of everything. But what science has innovated is our theories tell you where they stop. A good theory. They will tell you their limits. And they will say, this framework, here's the scope of these assumptions of this theory. So every scientific theory has its assumptions. And if you grant those assumptions, then the theory says, I'll explain all this other wonderful stuff. And so you get the scope of the theory, all this wonderful stuff that it can explain precisely. And you get the limits. Here's where I stop. Like space-time stops at 10 to the minus 33 centimeters. If you want to go smaller than that, sorry, I can't do it. And if you want to go to 10 to the minus 33 trillion centimeters, I can't get anywhere near that. So you're going to have a completely different kind of framework. So that's why I've read many of spiritual books and listened to lectures and so forth, and listen to them as pointers, and they're useful pointers, but they're not precise pointers. And in science, you get more precise pointers. Now, what's interesting to me is that the scientific pointers were evolved in a framework in which space and time were taken to be fundamental. Right, so that's many of the early science. There's some discussion that many early scientists in Europe, for example, had some Christian leanings, including Newton and so forth, or more mystical leanings, and that may be true, but their theories were just about space and time and objects and physical objects inside space and time, not about consciousness per se. The mathematics was not about a mathematical theory of consciousness. It was about the stuff we can see inside space and time. And there we could be precise, right? We learned that we, F equals ma. That's a wonderful starting point. Newton gave us that, and he gave us his gravitational law, F equals g, m1, m2 over r squared, and so forth. So he gave us these wonderful equations which changed humanity, and they're mathematically precise. But they were all about what we perceive and not about consciousness itself. And in fact, consciousness was sort of left out of the whole thing. So we had, on the one hand, science, which is entirely rigorous, but can't talk about consciousness. It just doesn't mathematically talk about it. And then we had, on the other hand, the spiritual traditions, which were talking about consciousness, but didn't have any of the precise tools of mathematics and so forth. So we've had these parallel streams, and that's why there's been a clash. Is we have this imprecise language talking about something important to consciousness, and we've had this very, very precise language talking about space-time and objects inside space and time. But now science is at the point where we can now say space-time is doomed, and we have now learned the mathematical tools of precision. So we can now take the ideas that the spiritual traditions have been saying for thousands of years and turn them into mathematics, which is not to eviscerate them and get rid of their vigor and so forth. It's rather to make them so precise enough that we can find out what's bogus and what is a useful pointer. None of it's true, right? The spiritual traditions will tell you, this is not the truth, it's just a pointer. So what are the limits of the pointer? That's what we can now do with mathematical models that we get from science. We can say, okay, we can now move into the spiritual realm and talk about pointers where we know precisely the limits of those pointers. And that's a real antidote to dogmatism, and really also forces you to use what you're told only as a pointer, so that you ultimately have to go within. And if consciousness is fundamental and you really are that infinite consciousness, this process we talked about earlier about going into meditation and letting go of every thought, it's letting go of all these pointers, even the scientific pointers. So when I go into meditation, the idea is, it is true that there is no scientific theory of everything. It's absolutely true. Every scientific theory has its assumptions, and it doesn't explain those assumptions. It assumes them. Those are the miracles of the theory. You could get a deeper theory that explains those assumptions, but then the new theory will have its own new assumptions. So it's just trivial to see that science, for all of its power, and I love science, I love that it has precise theories that tell you their limits. That's what's good about it. It tells you its limits and it's precise. But you can never have a scientific theory of everything. And so the meditation process is really a recognition of that. And it's saying, fine, in everyday life, do your science and make really precise scientific pointers. But on logical grounds, that the reality transcends any pointer. What reality? What is the reality that transcends any pointer? Well, that reality is nothing other than me, my consciousness, which is your consciousness. And so that's the whole meditative process then, is to go into utter silence and have a direct knowledge of that reality, not indirect through a theory or through pointers. But so it's not a cognitive knowledge, it's not an intellectual knowledge. It's deeper than that. It's much, much deeper. And so what's really happening in meditation is letting go of all the facades, all the beliefs, all the books I've read, all the scientific theories I know that are standing between me and myself, and just being and knowing directly who I am. And that can be scary. It's very, the false interpretation of myself as just a little avatar inside space-time. That's what I think I'm just a little body in space-time. That's what I am. Letting go of that is not easy. And ultimately, though, you already are just that infinite consciousness. You don't have to get there. You just have to understand. I'm already there. There's nothing I can do to be more deep than I already am. I am already that. it's letting go of illusion, just letting go of the illusion. And I can only do that now. So it's an interesting thing. So it's not about getting anywhere. It's not about achieving enlightenment or something like that. It's merely recognizing that all I need to do right now is let go of any idea about what I am. Just let go of all ideas about what I am right now. And what's left is what I am.
Yes, yes, yes. Yeah, yeah. It's yeah, and it's nice to hear you sort of describe it in that way, you know, sort of coming from the kind of like using the sort of science, but then ultimately how you arrive, or one, in a sense, one is almost, I don't know, forced almost feels like the wrong word because it sounds too coercive, but inevitably one arrives at the place which isn't none of the signs, none of the pointers, and I suppose this is a question I could ask, but in a way I sometimes almost myself think it's not a redundant question, because consciousness is all that there is. But that defining consciousness, the other thing I was going to say is like, it's nice that kind of came from that scientific sort of that path. But you know, and I've heard you talk with like Rupert Spira and things like this, and you know, it's you know, very much in line with those sort of traditions, which again are just saying the same things as like the Vedic scriptures did and stuff. But sort of defining consciousness. I mean, I imagine you've been asked this a number of times, and I think particularly perhaps if somebody comes from a materialist, or you know, maybe they don't even realize that they have those sort of assumptions, you know, that, you know, they see life as being a constellation of atoms and, you know, particles, you know, and if you want to go lower, like, you know, leptons and all of that. But then people might say, well, what define consciousness? I'm curious if you have in the past had that, or if somebody did ask you, you know, you're in a cafe, do you have a sense as to how you answer that? Like, what is consciousness?
Right.
Like, isn't how you describe it, rather. Yeah.
Right. So, and what you're pointing to is important, that almost all of my colleagues in the sciences are physicalists, right? And so they take the space and time as fundamental, and objects in space and time as fundamental, or space-time. And, you know, the Big Bang happened some 13.8 billion years ago, and life is a relative newcomer in the universe. And consciousness is an even later newcomer than life. And my whole stuff about consciousness is fundamental, and that's what you really are as consciousness, is nonsense from that point of view, because consciousness is somehow a consequence of matter. It's somehow you get matter in the right functional states, right computational states, then somehow consciousness arises. And that's, I would say, 99% of the scientific theories are in that kind of framework. And they're trying to show what kind of functions could do the job, right? It could be integrated information, could be orchestrated collapse of quantum states of microtubules. It could be global workspace architectures. It could be high order theories or first order theory. There's lots and lots of ideas out there. What's striking? And so I just want to make sure that it's what I'm saying is not the consensus. It's not even a minority view. It's less than a minority view. It's, I would say, less than 2% of my colleagues would give me any probability of being right. So I should be very, very clear about that. I'm not saying what is the scientific received view. I'm saying something that from my good friends and colleagues in the sciences think that this is complete nuts. So, or if they're not complete nuts, not worth the time. It's, you know, clearly we'll get this. And I'll just say that what I asked them is, what specific conscious experience can your theory explain? Taste of chocolate, smell of garlic. Give me one, right? You're saying you're going to start with these functional properties or architectures or whatever in space and time, brains or computers or whatever it might be, and you're going to explain conscious experiences. So what success have you had? What experiences can you explain? And right now the answer is none. And I think it's for principled reasons. And that failure, I think, is going to, see, that's what I like about science. At some point, my colleagues will realize, oh, it's not because we're dumb. They're not dumb. These are my friends. They're brilliant. They are absolutely brilliant. If it could be solved this way, I think they would have already solved it. So I take their brilliance as evidence that maybe we need to let go, as the high energy theoretical physicists are saying, we need to let go of the idea that space-time is fundamental. Our science is telling us space-time is not fundamental. That means reductionism is false. And that means reducing consciousness to neural activity or to some integrated information pattern or global workspace architecture or contents. That whole framework is false. So how do I then define consciousness, which is what your question was? Well, here I want to bring up something about how we learn the meanings of words. So if you're a parent and you have a 14-month-old kid and they're just starting to learn words, and you're starting to teach them words, the way you teach them is by what psychologists call ostensive definition. So the standard example they give, like in developmental psychology literature, is to say, well, so you're sitting there with Chris, you have 14-month-old Chris, and you say to Chris, and say there's a cat on a mat, and how do you teach Chris the word? What you do is you point and you say cat. That's what we call ostensive definition. You point to something and you give a word. Now, if you think about that, so there's a cat on the mat. So the child has a little problem to solve. They have a visual scene in front of them. And in that visual scene, there's mom or dad's arm pointing to a region of it. And there's a word, there's the word cat's coming out. Now, what are you going to do? I mean, they're not giving you, precise definitions. They're just pointing and saying the word cat. Now, it could be, there's an infinite number of hypotheses that the child could entertain. Maybe you're referring to just the ear of the cat, or maybe you're referring to a paw, or maybe you're referring to the fact that it's furry, or that it has black and white patches on the fur, or maybe it's the right paw and a piece of the rug, the mat. So the cat's on the mat. So you can see that there's an infinite number of hypotheses, and yet what happens? It works. At the right age, all mom has to do, or dad has to do, is point and say cat, and they get it. You might have to do 1 or 2 times, maybe 3 or 4 times, but they get it, and then they generalize properly to all those cats. So and by the way, when you point, you don't point and say, Chris. You say, Chris, that's a cat. But you don't say, Chris, that's a quadruped. You would know, you'd even to think that a parent would do that makes you laugh, because you know that you're screwing your kid. They're gonna get, yes. Or if you say mammal or thing, that's a thing. It's like, no, you're supposed to say cat. And so we actually know that it's called a basic level object, and parents without being trained and children without knowing know that this is how mom and dad are going to start. They're going to point, and they're not going to say the higher level category like mammal or quadruped or whatever it might be. They're going to give you what's called the basic level object description first, and they're going to not talk about parts of the object. They'll talk about the whole object. They're not going to point and tell you about an ear first. They're going to tell you cat first. So there's, in this language game of ostensive definition, the rules even without being taught the rules. So that's how we learn the meanings of words. It's all by ostensive definition. And so for example, the taste of cinnamon, all I can do is let you taste it. Here's a little piece of cinnamon or some cinnamon powder. Taste it. That's cinnamon. Okay, what have I done? ostensive definition. I've said, taste this. That's cinnamon. Have I given you a detailed explanation? No. I've done something trivial. I've let you taste it for yourself. And then I've said, here's the word. So in some sense, you did all the work. You created the experience of cinnamon. All I did was say, that whole complicated thing that's going on inside you, we call that cinnamon. So the cinnamon word is trivial compared to what went on inside you. Same thing with cat, the same thing with space-time. Every word is a pointer. That's so when the spiritual traditions say they're a pointer, it's in that sense. If you aren't equipped with all this deep understanding and experience inside you, my efforts to teach you, which are pointing and saying words, will fail. So now we come to your question, which is the word consciousness. All I can do is ultimately, I mean, as a scientist, of course, I'm going to write down a mathematical model of consciousness. But the word itself, the thing that I'm trying to model with my mathematics, all I can do is what mom and dad can do about a cat. They can point and say cat. And so there's no special problem here with consciousness. This is true of every single thing you learn. All people can do is point. If you don't have it inside you to understand, then there's nothing I can do to help you. So in the case of consciousness, all I can do is say, I can point to, well, the taste of an experience, the taste of chocolate, that's an experience, and that's consciousness. I can point to all these things, and if you get it, you get it, and if you don't, I can't help you. So now as a scientist, I can then say, I've pointed to consciousness in this way, just like mom and dad point to a cat. And that's what I mean by the word. And now as a scientist, I want to go further. I want to actually write down a mathematical model of it. I want to actually say, okay, so in the case of a cat, we might say, now I'm going to tell you about the DNA. I'm going to talk about and the evolution of cats. And so I'm going to tell you a lot more about it. So I'm going to give you a theory, and that theory will have its limits and its scope. And the same thing will be true with mathematical models of consciousness. So I'll have and I've published something that I've got a paper called Objects of Consciousness and Fusions of Consciousness, where I'm doing that. But I don't mistake that for the fundamental question that you're asking, which is, how do you tell people what consciousness is? I can only do it the way I can tell you about anything, which is by ostensive definition. And if you don't get it, I can't help you. You don't get sick. If you can't, for example, if you can't taste cinnamon, then there's nothing I can do. If you're colorblind, I can't tell you. I can point to an apple and say red, but you won't get it because you're not equipped to get it. So that's the thing.
I mean, and what you're saying to me just comes to mind is this notion that, in a sense, it is that which asks the questions. And I remember Rupert Spira, I think he defines it as that in which nothing else, that which cannot be defined in terms of anything else, but in which everything else can be defined in terms of, obviously sort of positing, essentially that it's fundamental. And it's the same, it's sort of like, and that's why, I think, sometimes, you have like kwans, and sort of like, is it in Zen Buddhism, you have these sort of, they point to things, and it's like a way for you to sort of just almost reflect, really, or perhaps almost trying to observe thoughts. And that's why I think sometimes guided meditations can be really helpful, because it gives you those insights, to actually and therefore, it is somewhat amorphous, but at the same time, it can be pointed to.
That's right. And the reason it can be pointed to is because you're it.
Yes,
right?
Yes, exactly.
Right? So what the pointers are doing is pointing you away from any particular concept you have of yourself, and saying, those are fine, they have their place, but you go deeper. You are deeper than that. And if you want to really know how deep you go, you have to let go of all the pointers. And that's my final pointer, is letting go of all the pointers and go into an utter interior silence and watch and know who you are without being able to put any words to it at all.
Yeah. Yeah. And so you obviously, yeah, you cite it in your papers, you definitely cite it in fusions of consciousness, like these both through citations of physicists such as I can never pronounce his name. The one he's got
At
long, he used
Princeton?
to have, yeah, he used to have long curly hair, or maybe still does.
Yeah, Nima
Keenmar,
Arkhani Hamed.
Nima, that's it. Yeah,
Right, right,
him,
right.
right, Ed Witten. But essentially,
David
and
Gross.
also,
Yeah,
right, and also citing, for example, like what happens if with the Planck scale. Essentially, if you go smaller and smaller, smaller, it requires more energy, and therefore you end up with a black hole. So
right.
that's one way. The physics is showing us that space-time is not fundamental, and the maths. And then
Yes.
you also couple that with the fitness beats truth theorem,
Right.
and it's those sort of two. You later in the paper sort of cite that these two. Somebody doesn't have to subscribe to either, or they might subscribe to none or one. You then, so I mean, maybe briefly, it'd be good to just describe the fitness beats truth theorem, and also I don't know if you've thought. I mean, I imagine you are most likely, if not definitely, familiar with Carl Friston.
Yes.
Yeah, I mean, yeah, I thought I just, yeah, I don't know anybody who isn't. But essentially, his notion of free energy minimization. When I read your work on fitness beats truth theorem, immediately just to mind, it just popped. It was like it's saying the same thing, that it's the account which you give of this sort of narrowing of perception is in a sense. I put here I put the FBT theorem is essentially, I'm almost asking you a question here, is essentially an energy minimization account of how systems accord themselves with a path of least action, in which mutations which enable animals or organisms to survive within their niche are afforded less surprise. Thus, as you increasingly channel out a path in state space, you become increasingly entrenched. I mean, does that make sense? Have you thought of Carl's work bearing on the fitness beats truth theorem before? Yeah.
Sure. Yes. Yes. So first on the fitness beats truth theorem, but what we did was to show that the physicists have told us that space-time can't be fundamental. And the question is, does evolution agree? I mean, we have a mathematically precise theory of evolution. Darwin gave us the ideas, and then John Maynard Smith turned them into mathematics in the 1970s, and we have evolutionary game theory. And so I wanted to check. So in some sense, does evolution agree that that space-time isn't fundamental, and that the very fundamental objects like organisms competing for resources inside space and time, that ultimately even those are fictions. So that's where the mathematics of a theory can tell you not just the scope of the theory, but the limits of the theory, even critiquing the very fundamental ideas that went into building the theory, like physical organisms in space and time competing for physical resources, right? So we went after it, and it turns out the answer is yes. Evolution agrees with what the physicists are telling us, that ultimately the chance that our sensory systems are reporting to us objects in space and time. That's what they're reporting to us, right? That's what we see. The question is, what is the chance that our sensory systems are showing us any aspect of reality as it is? And the probability is zero. You can prove the probability is precisely zero. And so that means that the probability is precisely zero, that space and time and physical objects, organisms and resources in space and time is the true description of reality. Is the probability is zero. So evolution actually agrees with high energy theoretical physics on this. And so that's really good news. Our two best scientific theories agree: space-time is doomed. And again, we can go into, I've got a lot of pushback from philosophers and cognitive scientists. We can talk about the pushback. But then how does that relate to Friston's, so what we said then is, I should say, is that, so what did evolution give us? It didn't give us a window on the truth. That's what our theorem says. It's not a window on the truth. So what is it? Well, it's just a virtual reality headset. Evolution gave us a headset to play the game of life. And it's much easier to play a game like a virtual reality game with the headset than trying to toggle the voltages inside a supercomputer. Good luck trying to play the game if you have to toggle the voltage. If you know all that truth, you will lose to someone who just has a headset and can turn a steering wheel and push on a gas pedal and so forth. You will lose to that person. So that's, in terms of fitness, it's far more fit to know nothing about the truth and to have just a little user interface and hide all that complexity. So that's so fitness. It's actually more fit not to see the truth, and we see that in virtual reality games. It becomes pretty obvious. Have fun toggling those voltages millions per second in the right order, in exactly the right order, if you want to actually win the game. Good luck. I'll just turn my steering wheel, thank you, and push on the gas. And so that's what evolution did for it. So the fitness beats truth theorem then leads to the notion that our perceptual system and space-time itself, which is the format of our perceptual system, is just a headset. So I like to say space-time is a headset, and all the objects in it are just objects that we create on the fly inside the headset and then delete them, right? So I'm playing Grand Theft Auto with my VR headset on, and I see a red Ferrari to my right. Well, I'm creating that Ferrari when I look, and then I garbage collect it. I throw it away when I look away. The Ferrari is only there when I look, and I create it as I need it. So, and this, by the way, explains a lot of the weirdness of quantum mechanics. But we can go to that later. I mean, basically, objects don't have any of their properties unless they're observed, because they're actually created in the act of observation. Their position only exists when you observe them, because you create them when you observe them.
And I think that speaks so much to this notion of, consciousness as, yes, being fundamental, and space-time is predicated upon consciousness, and right. And that and I think it's so important because I can do it. Maybe it's easier for you because you spent a longer thinking about these ideas, but I imagine as well, people, when they're really new to thinking like this, when you talk about the headset and things like that, it's easy to sort of think of the headset being in space-time, whereas it's not. It's a metaphor for how consciousness projects itself.
Right. That's right. Space-time, the space-time that is billions and billions of light years long and out there and amazing, and that's just our little headset. That's what I'm saying is the headset.
Yeah.
That is that then makes you pretty special, because that's just your headset, and you transcend that headset dramatically. So this leads to the question, who am I, is pretty equal. So yeah, you're right. So it's not a little headset inside space-time. It's rather that the space-time itself is just a little headset inside you.
Right. And that also that which, this again, this is a metaphor, the headset, but it's from what you spoke in Fusions of Consciousness, the paper, you speak about how, conscious realism, and fundamentally all there is this conscious network. Right. And that the distinction between animate and inanimate is sort of objects is somewhat arbitrary, and for example, things like rocks or like mountains, you say that they exist, but they exist in service of basically being a node in a network, a conscious agent rather, being able to communicate with another conscious agent. Is that right?
Right. So the idea is that this is a complete shift in framework. So almost everybody thinks that space-time is fundamental, and there was the Big Bang, and there were no consciousnesses there. In fact, life wasn't even there. Life and consciousness are latecomers, and so we have to figure out now. We have a scientific problem. How do we distinguish living from non-living? What physical systems are living? So is a virus living? Is a bacteria living? Yeah, bacteria, yeah, virus, yeah. How about a strand of RNA? Is that alive? I mean, then you start getting debates and so forth. And then also consciousness, right? Most of my colleagues and friends doing consciousness research, they're assuming that most physical systems are not conscious. There are some panpsychists, and we can talk about that, which say there's consciousness behind everything, but most are not panpsychists. And so they have the question of saying which physical systems are conscious and which ones are not. And my attitude is that whole framework assumes that space-time is fundamental, and that assumption is false. And so the distinction that they're trying to make between living and non-living and conscious and unconscious physical objects is very much like, here I am on a Zoom with you, and I see your room on my screen through pixels. And some of the pixels are pixels of your face, your eyes and your mouth and so forth. And I'm getting, I see expressions, and I get some insight into your consciousness from it. But then I also see pixels of the wall and the floor and so forth. And I'm not getting any insight from about consciousness. So should I say that, oh, okay, these pixels over here, those are conscious pixels, and those pixels over there, those are unconscious pixels? Well, no, that's drop dead dumb. Pixels are pixels. They're not conscious or not. They are, consciousness is whatever it is. The Zoom screen is an interface. I'm interacting via, and so I'm getting a portal into your consciousness from some of the pixels, but that doesn't mean the pixels themselves are conscious. That's a rookie mistake. And the pixels for the floor are not dumber or less complicated or whatever than the pixels for your face. So that's the way it is. And so the principal idea here is that the distinction between living and non-living and conscious and unconscious in the framework that I'm talking about is not a principal distinction. Consciousness is fundamental. My headset, space-time is my headset, and the headset is dumbing down. That's what headsets do. I mean, the interface is there to simplify stuff because you don't want to deal with the complexity. So that's what it's there to do. It's there to dumb down. So it's not going to show you consciousness in its full glory and all this. It's going to dumb it down. And most of the time it dumbs it down so much that you don't even recognize it as consciousness. I see a rock. I see a mountain. It doesn't look conscious at all to me. I don't have any insights at all. So that is the sense in which I say that once you let go of the physicalist framework, that let go of space-time being fundamental object in space-time, then you have to let go also of what scientists thought were important problems: the distinction between living and non-living, and the distinction between conscious and unconscious. So my brilliant colleagues who are studying consciousness are trying to get mathematical models that show that these physical systems have to be conscious and these ones cannot be conscious. And the whole question, the whole framework is doomed from the get-go. The whole framework is wrong, so that their theories they're just spinning in circles and they'll never get there. It's like, again, it's like asking which pixels in my screen are conscious pixels and which ones are unconscious pixels. But you asked about how does this relate to Friston's stuff, and Friston has the notion of first that our sensory systems and the entire organism is in some sense trying to predict what's going to happen. It's a predictive processing kind of model, right? So you're getting all this sensory information coming in, but you have a model of who you are and what your environment is and what you're expecting to have happen. And what you're trying to make sure is that things don't happen that are unexpected, right? I don't want a tiger leaping out of unexpected on me. I don't want to fall off a cliff unexpectedly. I don't want to think I'm eating a grape and I'm actually eating poison ivy. I don't want that kind of stuff to happen. So I need to have these predictive processing models. And there's the notion of an interface. He talks about Markov, what we call Markov blankets.
Yeah.
And I call that an interface. Markov blankets are a technical term in the theory of Bayesian networks, which are directed acyclic graphs and so forth. And they have a technical meaning in that context. They're, if you have a set of nodes in a network, the Markov blanket is the parents of those nodes, the offspring of the nodes, and the parents of the offspring of those nodes. So that's that's a technical definition of what a Markov blanket is. And it's a theorem. Judea Pearl at UCLA and his colleagues have developed most of this. They show that the states of the nodes inside the Markov blanket and the states of the nodes outside of the Markov blanket, the world outside of the Markov blanket. So think of the blanket as my skin. So here I am on a bunch of nodes. The Markov blanket is my skin, and there's a bunch of the nodes outside of the world outside. Well, the state of the nodes inside and the state of the nodes outside are conditionally independent given the states on the Markov blanket. And what that means is That's a technical way, but what it means is all I can know about the reality outside of me is what's on my markup blanket. That's it. That's all I can know. That's a user interface. So in particular, all I see, my experience is of space and time. Well, that's part of my markup blanket. That's just a user interface, and that's not the truth. Because the truth is conditionally independent of my states given my markup blanket. It's conditionally independent. So I can't know what the truth is beyond my experiences. So now I don't think that Carl Friston embraces that last conclusion that I said. So I think he would agree with everything else I've said, but I think he would disagree with me on that last point. A good friend of mine, Chris Fields, that I've done many papers with, and really good. He collaborates quite a bit with Carl Friston right now. So at some point, it'd be fun to have a conversation with Carl on this little technical point and see what he says.
Yeah, yeah, it would be, and I can't remember exactly because it was a couple of months ago. But I had a conversation with him, and similar to how we are with Carl, that is. And I sort of related the question in a similar way. And he spoke about like this sort of like Waddington landscape in which, and that kind of like, and that's what I was sort of, because it seems to me like phylogenetically, across like these large temporal scales, the user interface, the headset, the interface, as a consequence perhaps of mutations, will become narrower and narrower, and to the point whereby, I mean, you say that it's our sensory systems see nothing, like essentially nothing of, and this is interesting when you say nothing of the world as it is, because I think when someone hears that, they could think that means that what you're saying is that it literally has no bearing on it. But is that necessarily the case, or is it more that and you've used a word before, is it holomorphism? But essentially that our interface, it's not that it has some, or maybe not, but some, it's tethered in some sense to the data structures which underpin it, right?
Right. Yeah, there is a connection, and the mathematical way of saying it's a projection. So what we perceive, space and time, and for example, Darwinian evolution inside space and time and so forth, is a projection into a particular data format, the space-time format, of a reality that is far richer. So mathematics is a projection, and the mathematical model of consciousness that we're working on is the mathematics is Markovian dynamics is what we're using, is Markov chains. A Markov kernel is a matrix, an n by n matrix, and each row, the elements in each row are between 0 and 1, and they sum to 1. And so we have that Markovian dynamics, and what we can show is that dynamics need not have increasing entropy, right? The entropy of that, so it's a dynamical system outside of space and time. It does have entropy, but the entropy doesn't need to be increasing. So there need not be an entropic arrow of time in our dynamics of consciousness. But it's a theorem, and it's elementary. It's a three or four line proof that if you take a projection of such a dynamics, a Markovian dynamics, by conditional probability, where you're losing some information. So I have this dynamical system. I'm getting a new dynamical system, a projection dynamical system, which has lost a little information about the original by conditional probability. So, but I'm seeing a new dynamical system. That projected dynamical system will necessarily have an arrow of time. It will have an entropic arrow of time. So the way I view it then, so evolution by natural selection, which I love. I mean, it's an incredibly beautiful theory inside space-time. It's about limited resources and competition, organisms in space and time competing for limited resources. What is the most fundamental limited resource? Well, it's time. If I don't get food in time, I die. If I don't mate in time, I don't reproduce. If I don't breathe in time, I die. Time is the fundamental limited resource. And what we're saying is our theory of consciousness, the dynamics, says we don't have to have this arrow of time. But in any projection, you will get an entropic arrow of time. So my view right now is that as beautiful as evolutionary theory is, and as powerful as it is, and I've my book, The Case Against Reality, goes into how beautiful it is. I mean, I spent a lot of time, and I fawn over evolutionary theory. It's beautiful. But from this other framework, this deeper point of view, I'll have to say, every aspect of evolutionary theory is entirely an artifact of the loss of information in the projection. None of it is a deep insight into the nature of reality beyond space-time. The very arrow of time is an artifact. The notion of organisms competing for limited resources, all of that is not an insight into the deep reality beyond space-time. All of it is a projection and an artifact of projection. So when you have a projection from some bigger system down to a smaller system, sometimes you might say, well, part of the projection is what we call homomorphism. I'm not seeing the whole structure, but I'm seeing something, a good shadow of the structure. The shadow that I see has a similar structure to the real thing.
Right. Yeah.
Whereas what I'm saying here is that time itself may be utterly alien to what's going on beyond space-time. And if time itself is utterly alien, then evolution in time, the very notion of evolution, is entirely an artifact. And this is, again, getting back to our earlier discussion about reality and the pointers to reality. We really have to take that seriously, not only in the spiritual traditions, but in science. A projection may not be a homomorphism. It may actually introduce all sorts of artifacts. And what we can do is write down our theories of, say, okay, we don't know what's beyond space-time. So we write down mathematical models. And so we wrote down this Markovian dynamics of conscious agents. And then the mathematics came back and said, well, if that's your model of what's beyond space-time, you don't need to have an arrow of time out here. And if that's the case, then the arrow of time inside space-time is not an insight about reality. It's entirely an artifact of the projection. And then everything that follows from that, organisms competing for resources in time, is not an insight. It's not who we really are. It's not a deep, it's all an artifact, an illusion of the projection.
Yeah.
And so our first conversation on pointers then becomes really critical right here as well. This is, again, more mathematical about these pointers.
Yeah. And so in sort of like Kantian terminology, then it's kind of like, sort of like evolution and space-time, I suppose, are phenomena.
Right.
And consciousness, in a sense, is the thing in itself.
Right.
And I don't know if Kant actually explicitly say. I mean, his works are voluminous, and I've not, I've only sort of read commentaries and stuff on them. And I don't know if he's explicitly said the consciousness is the thing in itself. But I got the sense that that's what he was getting at. And because I've read a bit more Schopenhauer, I mean, Schopenhauer very much, I think, if he read or some of your work or heard what you were saying, he would very much agree with. This notion of, he used the word the will, but I think in a way it's very much sort of commensurate with this idea of consciousness. And he actually said that, he talked about like the subject that looks out upon the world from every like creature or something to that effect. And this, so then if we're talking about the noumena, consciousness, you postulate then that is fundamental, and that we are agents, conscious agents, though we are embedded, or that we are a part of the one, like this one consciousness, but that we cannot start with the one. We have to somehow, like you talk about, moving up some hierarchy, Kantov or Cantor's hierarchy, to get there. So
I can talk a little bit about that if you want.
Yeah, sure.
Yeah, so once again, I should say right up front that my mathematical model of consciousness is just another pointer, right? It's not the thing. So my mathematical model of consciousness is not consciousness. And the only way, as your earlier question was, so what do I mean by consciousness? All I can do is give you the following pointer to consciousness, which is to say, let go of every thought, let go of every emotion, sit in utter silence, and stay there for a while. In utter silence without thought. That is, you're now in direct experience of what I'm talking about, this consciousness. And the more you do that, the deeper you'll go, and the deeper this pointer will go. But no concepts. So I can tell you, just like telling you, here's some cinnamon, taste it. Yeah. All I can do is say, taste it, and here's the word. Here's what I'm saying. Here's how you taste it. You sit in absolute silence, let go of every thought, every emotion. It's not easy. It may take a long time, but the more you do that, the more you're going to see the pointer that I'm using. And for most people, you can't do it, right? I mean, sit down and thoughts just go through your head and emotions go through, and you sit there for an hour and go, I didn't have a time. The pointer didn't work for me. 1,000 hours. So spend 1,000 hours. Then it took more than 1,000 hours for me. So I've been at it for more than 30,000 hours. It's starting to work. So this is a pointer. It's a real pointer, and it goes very, very deep. But it's not as easy as just tasting cinnamon. But that's my pointer, and it's the pointer that spiritual traditions have used for thousands of years, and it's a good pointer. But so my mathematical model is absolutely not the thing, absolutely not. But as a scientist, I'm trying to take the next baby step in getting a mathematical description that's a baby step pointer that for the first time in any spiritual tradition, we would have pointers to spiritual ideas, spiritual things that tell you their limits. Finally, we have pointers that say, here's where I stop. That's what we've never had. No spiritual tradition has had mathematically precise pointers that say, thus far and no further, with mathematical precision. So that's what my goal is my pointers will never be the truth, but at least my pointers for the first time will tell you, I stop here. That's the goal of what I'm up to right now.
When you say I stop here, sorry.
Yeah, go ahead.
I was just saying, when you say I stop here, do you mean you as a conscious agent, no? No,
the theory as a pointer.
I see. I'm with you.
Yeah. The theory. See, my theory of conscious agents is just a pointer to consciousness. I gave you. So I've given you two pointers. One pointer I've given you is if you want the real thing, the real taste of cinnamon, sit in silence, maybe for thousands of hours. That's the real thing. If you want a pointer that I can tell you is not it. Here's the pointer that's not it. My theory of conscious agents, this mathematics. But the nice thing about the theory is everybody else has been giving you the Upanishads and the Tao Te Ching, and the Tao tells you that it's any word is not it. So that's good. But it doesn't tell you how far you should take, where do the words stop? Where is their limits? And that's what the mathematics does. It says, for example, it's quite humbling. Our mathematics says that, great, you got a mathematical model of consciousness, but the one consciousness is literally an infinite number of infinities beyond what you can describe. So it's an infinite number of infinities beyond what my mathematics can describe, in principle. So that's very, very humbling. But once you know that, then you can't be dogmatic about it. On the other hand, what's interesting is this other question, which is in this whole framework in which there's this infinite consciousness, and that's what you are, and that's what I am. And you and I are just the one consciousness talking to itself through two different avatars right now. That's all that's really going on here, is there's this one unbounded, undescribable consciousness talking to itself through two avatars. Why? Why is it doing that? Why should that which transcends any physical form bother to take on physical forms and go through this exercise? And the right answer is, I don't know. But again, as a scientist, I posit proposals. So one possibility is, and I've heard this from spiritual teachers like Eckhart Tolle, the kind of thing where he'll say, if everything were green, then green would be meaningless. You need contrasts. So what the formless one infinite consciousness, to understand itself as that unbounded formless infinite consciousness, needs a contrast. So what it does is it pops into different forms, lets itself get lost in this, says, I am just a little 150-pound kid or man trying to make a living, and I'm spent, and after 70 years with it, all of a sudden I realized, holy smoke, you wake up and go, oh, that's not what I am. I'm unbounded consciousness. And it's that process. But then I do it as a gardener, I do it as the president of the United States, I do it as the prime minister of the UK, I do it as a housekeeper, I do it in 8 billion different ways for humans. Who knows how many different ways as ants and monkeys and so the one consciousness is putting on all these different VR headsets with different avatars and looking at it itself from different perspectives as a way of saying, what am I? Well, here's a countless number of things I'm not. I'm not a Don Hoffman, trying to make a living in Irvine, California, and I'm not a George Holiday and trying what I let myself think I was, and then I woke up and I learned something more about myself in the process. So that's one possibility, is that it's in the nature of this infinite unbounded unconsciousness that it will indefinitely and in infinitely many different ways look at itself from different perspectives and say, well, that is it's a fun perspective on myself, but I'm more than that. And here's another perspective on myself. I'm looking at myself now through the lens of being an ant. Now I'm looking through the lens of being a baboon. Now I'm looking at through the lens of being, a virus. In all these different lenses, I'm looking at myself through that. And that changes the whole problem of evil too, right? And this is just a VR headset. So I'm not proposing bad behavior, but if you're in a VR game, if you're identified with the avatar, then everything that happens is you're going to feel is morally wrong. I mean, they're actually hurting me. But if you actually go into the game and it's a bunch of buddies and these are just avatars, you might punch each other and so forth, and and then take off your headset and laugh and go have a beer, right? Because it was just a game. So there's some interesting implications again for what's going on there. Again, I'm not using that to say that it's going to loosen morals. And in fact, I think the opposite. When you realize that the other avatars are really you, it's really you that you're punching. It's really you. That is true love, and that's the true source of true morals. And so that's what you really are learning, is to recognize yourself in the other, the beggar, the person that's cut you off on the road when you're driving, to recognize that's me. And so ultimately this point of view doesn't lead to an amoral kind of thing. It leads deeply to the deepest moral, which is love your neighbor as yourself, because their avatar is you're just an avatar of yourself. So but on the other hand, it also leads to sort of a lightness, because ultimately you're just going to take the headset off anyway. and nothing was lost.
Yes. Yeah. It's oh, it's funny. I mean, I've had experiences which just chime with it very much. You know, I remember when I was about 7. I don't know, maybe I was a bit older. I was a child, but I remember I looked. No, I must have been a bit older actually, because it was when we had a dog. But I looked. I was probably about 10, 11, and I looked at my dog, and I saw my dog look back at me, and it's really strange. And I thought, what's the difference between my dog looking at me and me looking at my dog? And then for some reason, I had a grandfather who I never met. And I thought, once upon a time, my grandfather looked out upon the world in the same way that I'm looking upon the world, and yet he is no longer here. So what's happened there? And where did I come from? But it was strange because in that moment, I somehow recognized that it's so strange, but that somehow I recognized that I was that which my grandfather was, even though my grandfather was not there. And yeah,
Yes.
it's just yeah, it's funny, you know, and how you have these moments. And I think that's why, you know, I've very much drawn to reading your books and your papers, and you know, and listening to, I mean, podcasts especially as well. Like, you know, you've had conversations with Bernardo quite a lot, right? Yeah, and Rupert Spira, and I think it's just so great, you know, to actually, because you know, and Bernardo's very sort of you know, sort of quite loud on this. I don't know if loud is the right word, but you know, he's quite clear in, you know, his deconstruction or materialism, you know, and its limits, and what, you know, and it's nice to have, because I mean, I studied cognitive neuroscience, and I found it quite. I remember when I first started studying it, I found it quite. Oh, it was quite. There was something quite draining about it, or just spiritually depleting. It was like, really, what, everything is reduced to these abstract things? I was like, that doesn't seem right, and it didn't feel right. And then I kind of reacquainted myself. You know, I sort of, because I'd read sort of like the Upanishads and stuff in the past, and yeah, so it's nice to see. You know, you've got obviously like these sort of you know, Leibniz, Kant, Schopenhauer, you know, it's not exactly like, you know, new even in the sciences. And actually the quantum, a lot of like the physicists, the quantum physicists, I mean, you know, they all appeared to be quite, you know, in tune with, I'm not saying necessarily exactly your, you know, what you describe in terms of like the projections and stuff, like in terms of, but at least in the sense of consciousness being fundamental, you know, they were you know, there's quotes you can, I think it was Max Planck who said, you know, you can't get behind consciousness, you know, and so, you know, it's not like an alien line of thought or intuition which humans have had. And yet, as a, you know, a person who's grew up in Western culture and education systems, you can't help, you're sort of like, you're showered with these notions of, no, there is only, you know, space-time, there is only atoms. And so yeah, to be reminded that actually, yeah, you know, not only is this you saying this, but you know, you've got philosophers, you know, and people, you know, from who meditated thousands of years ago, and it makes me, really does make me curious to, you know, the future of, like, I don't know what you call it, like the scientific metaphysics in a way, really. And why is it so obstinate? Why is it so entrenched in this kind of, like, you know, you say it's like the 2% of the 2% of your colleagues or whatever who are sort of in line with you, like agree with you at the same table, you know. I don't imagine though you just like have a canteen whereby it's like your lunch tables are defined as to whether or not you see consciousness is fundamental or not. But you know what I mean. And so yeah, it's good, you know.
Yeah, I'm a cognitive neuroscientist, and I love studying the brain, and the work that's being done there is incredible. And I've participated in fMRI and EEG studies, and then I've done mathematical modeling. And so I'm all for cognitive neuroscience. My friends and colleagues are cognitive neuroscientists. But I think it's much harder than they think. They look in the brain, they say 86 billion neurons and tons of, maybe 84 billion glial cells in the latest count and so forth. It's a complicated thing, but from my point of view, that's just the headset view. That's just the interface. What's behind the interface? We have to what we see when we look in microscopes and brains is we see neurons and synapses and so forth and glial cells, but that's just in our headset. We have to reverse engineer all that stuff and find out what's outside of space and time that's projecting down to what we call neurons and glial cells and so forth. So we need more funding for cognitive neuroscience, not less. It's much more complicated than we thought. And it's true that most of my colleagues are physicalists, and they think that my ideas about space-time is not fundamental and consciousness may be fundamental and we should get mathematical. I mean, I'm sanguine because in science, failure of a theory becomes at some point obvious. And it's starting to happen in the science of consciousness, the physicalist science of consciousness. They're starting to form a circular firing squad now, and they took out IIT. Some of them, so more than 100 wrote a thing, and they're firing on IIT. Well, there will be return fire because none of these theories can give you an explanation for any one specific conscious experience. There's not one. So once the circular firing squad starts taking off, there'll be no theory left standing. All the physicalist theories will actually be viewed. And now I think the label of pseudoscience was wrong. I think that you shouldn't call IIT pseudoscience.
Sure.
For a scientific theory to be wrong doesn't mean it's pseudoscience. Every scientific theory is ultimately limited at best.
Mm-hmm. Mm-hmm.
And so it but none of these theories can explain even one conscious experience, like the taste of chocolate. So if the idea that consciousness is fundamental and conscious agents are a good first baby step in science outside of space-time to model consciousness, then the proof will be, can I, for example, use the theory of conscious agents beyond space-time first to predict something as simple as possible, like the scattering of quarks and gluons inside of a proton, right? Something as 86 billion neurons and 84 billion glial cells is a lot to take on for your first forward. So let's see if we can model something like protons and gluons inside the quarks and gluons inside a proton. But then ultimately, if this is right, we'll be actually able to predict stuff inside space-time and get new technologies. So I'm actually sanguine that, I mean, put it this way, when Einstein got his Nobel Prize in 1922, the Nobel Committee went out of their way to make sure that it was clear none of the Nobel Prize was for his work on special and general relativity, none of it. They didn't believe it, right? Well, it was one of the most brilliant contributions ever in the history of science. And the Nobel Committee, these were well-educated people. They didn't like it. They didn't believe it. So, but eventually it took over, and eventually it won. And so eventually my colleagues, when 20, 30 years from now, it's still the case that I can stand up and say, or someone can stand up and say, so give me one. What specific conscious experience can you explain? Oh, you still can't explain one? Well, maybe it's time to let go of physicalism. The physicists, the high energy theoretical physicists have let go of space and time, and they've let go of reductionism. Maybe it's time for cognitive neuroscientists to catch up with what the high energy theoretical physicists have been telling us since at least 2005.
Yeah, exactly. And it's funny because when you say that, I think, well, it's funny because David Chalmers, was it 95 or around then, he coined the term the hard problem, right? So it's not, I suppose time, it's relative, what's long, but it feels as though like nearly 30 years is, long enough to kind of start for more people to sort of like, jump over the fence and see what's on the other side, but it doesn't appear to be such. But then immediately I'm brought back to, and it's something I experienced myself, it's like trying to think beyond space-time. It's very difficult. And I think, it comes back to Kant, who spoke about, these are embedded in our faculties are endowed, to sort of see things through space and time. And so it kind of, in a way, makes sense. And I suppose one has to sort of, it would be pointless to try and push up against it, because it's very, I mean, it's hard. And it's not, and I don't mean hard in the sense that I'm doing it and other people aren't. I mean, I think there's probably elements of temperament. I think some people probably, I do believe, anyway, this is just me, that, I think people's temperaments can make them perhaps a little bit more sensitive to like a materialist or an idealist sort of, and like consciousness being fundamental sort of perspective. But even, once you account for that, it is, I mean, I struggle talking to you now, and, and that's why I find metaphors very helpful and things like this, because it is very difficult to actually imagine or even think without being embedded in space and time,
That's right. So that's where mathematics becomes an essential tool. So the physicists, right, the high energy theoretical physicists who are saying space-time is doomed, they're not just saying space-time is doomed, they're saying, let's go find out what's beyond space-time, right? And they're doing it, right? They're actually succeeding. They're not looking for things, not just things like curled up inside space-time. We're talking about, let's find structures utterly and completely prior to space-time, beyond space-time. And you go, how in the world can you do that? With mathematics, you can. So they found stuff. So they found the deepest thing apparently are these things called decorated permutations.
You mentioned it in your papers. You mentioned it.
That's right. So
I don't understand. I mean, like, broadly speaking, I mean, what is that? Just that is some sort of structure which can predict or like make probabilistic inferences around things that happen in space-time. What is it?
Well, decorated permutation is actually a fairly simple idea. So, but the fact that it captures so much is profound. But a permutation, if I have the numbers 1, 2, and 3, a permutation might be, well, first is 1, 2, 3. That's the identity. Then I could have 2, 1, 3, 3, 2, 1, 1, 3, 2, and so forth. There's three things. There's 6. There's 3 factorial or 6 permutations that you could have of them. But now, if you notice, when I go like 1, 2, 3 goes to say 2, 1, 3, that permutation. The 1 got moved forward. 1 went to 2, right? But 2 went backwards. 2 went from the position 2 back to 1.
Yeah.
So that's a normal permutation. Sometimes a number moves forward, sometimes a number moves backward, right? In a decorated permutation, you only move forward. So, and if you go past, like if you 1, 2, 3, if you go past 3, if you needed to go past 3 to get, you assume that what the real permutation is like, it says, so I move, if I, instead of saying 2, 1, 3, that 2 is in the first location. If I call it 4, if I say 4, 1, 3, then, or 5, 1, 3, that means I've moved. So instead of moving the 2 to the 1 location, I move it past the 3. I move it to, past to 5. So I would call it 5, 5, 1, 3, something like that. So in other words, you always permute to the right, and then you take the actual permutation to be the bigger number mod, like 3 in this case, mod 3. So decorated permutations are, you only permute to the right and then take it mod n, whatever the number of n items is. That's the technical definition of decorated permutation.
Right.
But what has surprised the physicists is that these decorated permutations, in some cases, contain all the information you need to describe the scattering amplitudes of particles in space and time. And so is truly stunning, right? To compute these scattering amplitudes in space and time using quantum field theory, like for 2 gluons smashing into each other and 4 gluons spraying out, is hundreds of pages of algebra if you do it inside space-time. But if in the new math outside of space-time, 3 or 4 terms that you can compute by hand. So and then you see new symmetries that are true of scattering amplitudes but can't be seen inside space-time. And so what they're finding is, first, our math says space-time is not fundamental and reductionism is doomed. But we're finding these new structures outside of space-time, like these decorated permutations. They make the computation of scattering amplitudes much, much easier, like hundreds of thousands of times easier. And they're showing us new symmetries that we can't see, that can't be seen inside space-time. So the race is on, right? They're finding all these structures. Now, what does it mean? That's a different story. I mean, we're finding these structures. They're letting us do all this wonderful stuff back inside space-time, but there's no dynamics. So, right, physicists like dynamical systems. So what kind of dynamical system outside of space-time might be giving rise to decorated permutations and then projecting to things like the amplitude-hedron that they found, whose volumes then give you the scattering amplitudes, the scattering process of space-time. And so what we've done in our fusions of consciousness paper, published in January, was to show that, well, if you posit a Markovian dynamics outside of space-time, or Markovian dynamics of conscious agents, for instance, we show that there's a beautiful way to project that down to decorated permutations. And so that was a new contribution, apparently, to mathematics. We couldn't find any papers on that. So I first went to look and see, surely someone's done that, and no one, as far as I could tell, had done it. So we did it. And Chetan and Robert Prentner and I in the paper, and we wrote down a couple maps, actually, from Markov chains to decorated permutations, and also from graphs to decorated permutations, arbitrary graphs to decorated permutations. So, and now what we're doing, we're about to do another paper we're going to call Traces of Consciousness, in which we now take our decorated permutations and show how they map on to the decorated permutations of the physicists. Basically, ours sort of classify what are called the recurrent communicating classes of Markov chains. Theirs classify linear dependencies, sequential linear dependencies among vectors. And so we're going to show how we can map our Markov chain recurrent class decorated permutations onto their linear dependencies decorated permutations, and then we'll have a path all the way through to from consciousness to scattering amplitudes in space-time. So we'll actually have a theory of consciousness outside space-time and a dynamics. That's the key thing. Now there's a dynamical system that says, here's where the decorated permutations are coming from. Your linear dependencies are really a projection of these recurrent communicating classes decorated permutations, which are a projection of these Markov chains. So it's the mathematics is several steps, and that's why it's taking us some time to put all the pieces together. But this is the kind of thing that when it finally pans out, then I think my colleagues that are doing cognitive neuroscience inside space-time will go, oh, okay, so we have to change our framework. And the consciousness doesn't emerge from neural activity. Consciousness is prior to space-time itself. Consciousness gives rise to space-time, and it gives rise to neurons as a headset representation. And here's the mathematics. The real win will be when we start using the mathematics to make new technologies. Right? With this, we're having a dynamical system of entities outside of space-time. And we're treating space-time as merely a headset. That's going to open up incredible technologies. Like, for example, if I go through space-time in my headset from here to Andromeda Galaxy, which is the closest galaxy to the Milky Way galaxy, I think it's about 2.4 million light years away. So it would take, at the speed of light, our rocket ship 2.4 million years to get to Andromeda. Well, good luck. My great-grandkids, my great-great-grand, many, many generations are going to die on the ship before we ever get there. We're not going to Andromeda any time soon, and that's our nearest galaxy, and there are countless billions maybe trillions of galaxies out there. So we can't even get to the nearest one. So holy smoke, there's all this real estate out there. We can't get to the nearest one, not even if we go through space-time. But if space-time is just a headset, we don't have to go through space-time. We can go around it. So for example, I'm playing Grand Theft Auto and I'm a wizard. And I know how to drive through the Grand Theft Auto space at breakneck speed, and I know all the. But if I'm a software engineer, I know the software of Grand Theft Auto. I could take the gas out of the tank of the wizard, out of his car. I could change the geometry of the roads, and I could just move his car from A to B without going through the space. I can do whatever I want because I've got the software. So that's what's going to happen. We'll have the first level of software, right? We'll never get the whole thing, but the first level of software outside of the headset will allow us to have magical technologies that will make everything we've got so far look like little tiny pipsqueak firecrackers.
That's amazing. Wow, that's quite it's almost yeah, I mean it's like I mean, if if it came out, it'd be classed as sci-fi in a movie, what you're talking about.
Well, what we're doing right now, to someone from 1800 in London, if they saw what we're doing right now,
oh, of course, right,
indistinguishable from magic, right?
Yeah, for sure. Yeah, definitely.
So there's this place in California. It's for how many thousands of miles, several thousand miles away, 8,000 miles away, and you're talking instantaneously with this. No, I don't believe it. Don't believe it. This is all nonsense, or some kind of weird magic. No, it's just Maxwell's equations. Put to good use.
Yeah, there's so many questions. I mean, it's like, I suppose it's only speculative at this point, but when you say that, would it be like my arrangement within space-time actually moving, or more it's a case of refiguring space-time around me, as in like, because you can't go through space-time as me, as George, as a human, because it's too far. So then somehow like I would like get sort of moved around space-time, or it's more like a question like, well, maybe we can actually reconfigure space-time.
Well, again, we're taking space-time now too literally and too seriously as something real. Remember that space-time is nothing but a set of experiences that you're having. And so all we need to do is to just change the experience.
Yeah, okay.
Now you're at Andromeda.
Right.
And it'll be the same experience as if you went through space-time to Andromeda. But see, we have the whole network of conscious agents outside. And so we know what part of the network corresponds to Andromeda in your space-time headset. And we can just change the connections. So now again, I'm talking at top level. We'll have to actually get all the mathematically precise statement of the Markovian dynamics, and look at it and see the mapping into our Markov blanket, our interface. And once we have that all, and that's what I'm having fun working on right now. That's what I'm working on this week. And last week, that the project we're having right now, we're connecting right now our decorated permutations with those of the physicists. Once we have that completely worked out, then we will have a map. Then we have some work to understand all of the steps that the physicists take, right, from their decorated permutations through differential forms and so forth, amplitude and differential forms. So we have to do a little homework on our part to understand their technology. But once we understand that, then we have the mapping all the way through. And it's not true. I mean, it's taken them decades to put the stuff together. So we may need to I'm working with Chetan as a physicist, but you can't know everything in physics. And so he and I, we're working with Chopin Chandapatier, who's a particle physicist at Fermilab and at UC Berkeley. He's a professor at UC Berkeley, but he's an experimentalist, not a theoretical particle physicist. So we may, we're doing the best we can. We may need to have a real high energy theoretical physicists work with us to help us understand their part of the thing. But we're doing what we can right now, and if we can't read their papers and really figure it out, then we'll have to go to one of them and have them explain it. But that's their goal, is to have the map all the way from Markov dynamics of consciousness to actual scattering in space-time. Once we have that, then we can start filling in filling it out. Once we fill it out enough, we should then start being able to predict new technologies that can come out of this, the new magic.
Yeah, that's quite amazing. So, and then sort of coming towards the end, just because I'm mindful of the time. I was thinking earlier about language. Now I know, because language in a way doesn't really take place in space-time in a sense. It's, I suppose it projects into space-time, but it's sort of, it's somewhere between consciousness and space-time. And I was wondering, if you think of like a conscious agent and it's got its own like dynamics and sort of perceptions, and like these, it's in a certain state, and it can, it could, do you think, in a way, I mean, could language almost be seen as like a bridge, or like a way? Does that make sense or not? Or do you think that doesn't make sense?
In a metaphysical sense, that it's a bridge.
Yeah, like if you talk about like fundamentally there is consciousness and conscious agents, and that from that projected, like there is the interactions between them, and it leads to this projection of space-time. But fundamentally, if we are conscious, we are consciousness, and consciousness is experiential, and consciousness, ultimately yes, my perceptions perhaps do take place within space-time. But then I suppose it becomes a question of, is its consciousness, like as in the perceptions exist beyond space-time, or is it merely consciousness that exists beyond space-time? And actually, I just
I can say a little bit on that question.
Yeah.
One thing I would first say is that when I've been talking about space-time as a headset used by consciousness, it's only one of an infinite number of different kinds of headsets that could be used. So it's not that there's something special about space-time. In fact, in my view, quite the opposite. I think space-time is probably one of the more trivial headsets that consciousness can use, not one of the more special ones. It's probably one of the cheaper. We're probably dealing with one of the cheaper headsets right now. But there are countless. I mean, why only 3 dimensions of space and 1 of time? Why not 10 billion dimensions of space? And why not 50,000 dimensions of color? And why 5 or 6 senses? Why not 20 billion senses? I mean, so we're in a fairly impoverished headset. We have to think out of the box. We're so used to what we've got in this headset, but once you try, you realize, oh no, I can imagine something far more complex than this. And so there's nothing special about space-time. We're not limited by space-time. And our imagination can go well beyond space-time. And I suspect that there are countless headsets that are much more interesting. So now language is part of it. We talked about with the ostensive definition, right? We come to use words and think that we understand each other by this pointing and naming process. Here, yes, taste this. This is chocolate. You like that? Here, now, look, that's a rabbit. And that's the sun, and that's we point. I have no direct experience of your experiences, and in fact, there's a condition called synesthesia. These are people that have, when I look, for example, at a physical object, I see its shape and its color and so forth. Some people hear music, so they they hear stuff, and or the opposite, they hear a piece of music and they see an object. So every time they hear this, Beethoven's Fifth, this part of Beethoven's Fifth, they see this object, or when they hear this word. So we actually have evidence that your interface may not be exactly the same as mine. Your colors may not be my colors. And if I could actually get inside your headset, I would go, oh wow, this is a really cool headset. It's really different from mine. And I've actually talked with synesthetes, and had a chance to talk to them about their worlds, and it's they know that they're different from other people, and they don't want to talk about it sometimes because it's when you're kids and you say doesn't that letter taste wonderful? And you go, how's a letter? Why should a letter taste wonderful? I mean, you're weird, Johnny. I don't know if I want to be your friend, Johnny. You're talking weird stuff here. And so their sensory systems are so interfaces can be very, very different. And so even though we both seem to agree, and you say, yeah, that's the taste of chocolate. Who knows? If I could get inside your head, what I call the taste of chocolate, what you call it, if I got in your head, I would say, oh, that's what I call that's not the taste of chocolate. That's the feeling of an itch on the back of my hand. That's not the taste of chocolate. That's an itch. So it could be, and yet so language is being used as a way for us to think that we're communicating with other avatars. And it's a fallible assumption. It works in everyday life. It's good enough. I mean, I pass the chocolate and I get what I expect. Please, I'd like a cup of coffee. I get what I expect. But for all I know, in your world, the sensory experiences could be utterly different from mine. So language, in that sense, allows people with different interfaces to interact in useful ways.
Yes, it is. I see what you're saying, but in a way, though, you speak of conscious experiences as being, you can like probabilistically infer them. And in a sense, is that not sometimes what we're doing when we communicate? We're trying to, if I, as a conscious agent, discern that I'm in a particular state, I don't know, you could like crudely say, oh, I'm sad, right? And want to communicate that with, another conscious agent, which according to from what I can understand from your papers, fundamentally, that's all there is, conscious agents. And part of like a broad net, like a network, or to the extent to which that's a metaphor, I don't know, and so therefore my experiences or the state I'm in is partly contingent on you and how you are and you behave and you act. And so that's what I mean by it's a bridge. It's a means in order to get across. It's a way in which doesn't mean it always it's veridical in the sense that like I want but does that make sense in terms of shifting your position?
No, I agree with what you're saying. So here you and I have been talking for almost 2 hours and we've been using language, and in both of our heads experiences are changing. We're having cognitive experiences that are changing, and we learn something or we unlearn something in the process. And so absolutely, so language is a way that one consciousness in some sense affects the perceptions of another consciousness. Absolutely. Another way is to do something like that and just wave. There's another way that or to shout or so just the voice itself, or to shake your hand. So these are all different ways that one consciousness can affect another consciousness, but language, I agree, is certainly one of them.
Yeah, fascinating. Well, we're nearly at 2 hours, so I think we probably best wrap up. But it's been wonderful. So thanks very much. I mean, it's you do so many of these as well. I see. And I've seen several, and it's like I sometimes think, oh gosh, there's almost too many for me to watch. Just like there's one every week or two a week, and it's but it's wonderful though. I think it's really commendable, and I think it's great that you're doing it, and for people similar, positions to yourself, like, we spoke about people like Bernardo and Carl, but, I think it's, it's really something important. And, we talked about technology and, we have this technology to communicate and to sort of, I think that's what's great about things like YouTube. There's communities whereby people can like, communicate in like comment sections and things like this. So yeah, I've got a lot from, you and your time with other people, but for now it's been great sharing this time with you. And so thank you very much, Don.
Thank you for your kind invitation, George. It was really a great pleasure to talk with you, so thank you.
Okay, brilliant. And I wish you all the best going forward, just with life and and your work, and so take care.
You too. Thanks a lot, George. Good to talk. Okay.
All right, ciao.
Bye-bye.